it says the box is held and placed on a frictionless 45-degree incline by means of hanging a 0.5 kilogram hanging mass as shown above. Draw a free body diagram for the 0.5 kilogram mass and determine the tension in the spring attached to it. Okay, so I'm going to draw the free body diagram right on it. So it's going to have weight force on the mass from Earth. It's going to have a tension force on the mass from the string. Those two should look the same length since it's not moving anywhere and there's no change of motion. So we know the weight force is equal to 5 newtons. Therefore, the tension force must be 5 newtons. Part B says draw a free body diagram for the pulley and determine the tension in the string attached to the box. Of course, I didn't show the box here, did I? Okay, so I think I'm going to draw the free body diagram right on it. There's a tension force on the pulley from string 1. There's a tension force on the pulley from string 2. Now notice this thing's not changing in state of motion, therefore the angular acceleration is 0. The only way the angular acceleration could be 0 is if these two are balancing one another. So that means TPS1 must be equal to TPS2, and TPS1 must be equal magnitude as tension over here that we found. Because of equal and opposite reactions. So therefore, the tension attached to this must be also equal to 5 newtons. Part C says now determine the mass of the box. So I need to draw another free body diagram. I'm going to draw it right on this. So there's going to be a support force, or excuse me, there's going to be a weight force down on the box from the Earth. There's going to have to be a support force on the box from the ramp. And there's going to have to be a tension force on the box from the string. Okay. Hopefully you can see that this is the same length as that, and this is the same length as that, because it's not changing state of motion. Also, hopefully you can see that this angle here must be 45 degrees. And this is a right triangle, and this angle here must be 45 degrees as well. Okay, so a couple equations I can write here would be tension on the box from the string must be equal to the weight in the x direction, and the support on the box from the ramp must be equal to the weight in the y direction. We know the tension on the box from the string, that's the 5 newtons. And so this is going to be the weight of the box from Earth is going to be given by, see, that's the opposite side, so sine of 45. And so I can figure out what the weight is, and I get the weight to be 7.07 newtons. Therefore, the mass is 0.707 kilograms. That's the mass. Part D, it says determine the magnitude of the support force. So that's going to be equal to the weight, which is 7.07 newtons in the y direction. So it's going to be times cosine of 45 degrees because it's the adjacent one to this angle. And when I do that, I end up getting